Okay, this is lesson 5.6, the sine law, and to extend on the idea of the sine law from last year, something called the ambiguous case. You can use the sine law in a given triangle if you know an angle-side angle or an angle-angle side combination. We do not have to be in a right angle triangle. You can use this in triangles that do not include 90-degree angles. But let's talk about those two scenarios. Essentially what the scenario boils down to is if you have a pair, so that's an angle and a side that's opposite it, plus one other piece of information, so either another angle or another side. If you have that scenario, you can use the sine law, because if you look at the equation of the sine law, it's sine A over A equals sine B over B equals sine, not cos, sine C over C. So in order to complete an equation, you need, let's cover this one up, you need a complete pair, so A and A, plus either angle B or side B, and if you have that, you can solve for the one you don't have. There's one other scenario in which you can use sine law, and that's if you don't have a pair, you need to have two angles. If you have two angles in one side, you can always use the sine law, and that's shown kind of in this example here. We don't have a pair because we don't have an angle with its opposite side. Angle, we don't know the side. Don't know the angle, we know the side. We don't have that pair. But since we have two angles, we could first find the third angle by subtracting the two we know from 180. Then we have a pair. And once you have a pair, you can use either angle 75 or angle 35 to find either of the other two sides using the sine law. Okay, so that's a short reminder of how to use the sine law. We can write the sine law with the angles, capital letters, on top, or we can flip the sine law and write it with the sides on top. And if you flip the sine law, it kind of saves you a step, and it's set up for you to solve for a side more easily. So what I recommend is if you're solving for a side, put all the sides on top, put all the angles on the bottom. If you're solving for an angle, put the angles on top and the sides on the bottom. So let's try two examples. Actually, we're going to do one example, and I'll get you to try the other one. Let's do example A. So as I said, you need a pair, and we don't have a pair, but I've kind of spoiled already that since we know two angles, we can find the third angle. I'm going to label this triangle. We've got a X here, so I'm going to call this triangle X, Y, C. So I'm going to write a sine law using the letters X, Y, and Z, but first I'm going to find angle Y because we know two of the angles. So angle Y, I'm going to write it up here, is 180 minus 75 minus 35. 35 and 75 make 110. Subtract from 180, you get 70 degrees. So now I know Y, and now that I have a pair, I can use the sine law. We want to solve for X, so we need to write a sine law that includes our X's and the pair that we have. The pair we have is the Y's. We know side Y. And if you've forgotten, angles and sides that are across from each other are labeled with the same letter. So let's write a sine law. I'm going to put sides on top because we're solving for a side. So we've got X over sine capital X, that means angle X, equals Y over sine Y. And now I'm going to fill in what I know. I don't know side X, but I do know angle X. Angle X is 75. And side Y is 18. Angle Y is 70. And now our last step is we need to isolate for X. And to solve for sine X, we need to rearrange the equation. To rearrange this equation, we need to isolate for X. And to isolate for X, we need to get rid of the divide by sine 75. And the way we can do that is multiply both sides by 75, sine 75. So what that looks like is X equals 18 sine 75, there's the multiply by sine 75, over sine 70. and that should be something that you can type directly into your calculator if you're in degree mode. That's 18 sine 75 sine 70. 18.5, and we'll round to one decimal place. And if you take a look proportionally, that makes sense because angles and sides should be proportional. We've got 70 degrees across from 18, and we got 18.5, which is across from 75, which is slightly bigger than 70. All right, you can try example B now. If you want, you can do it now, pause the video. If not, pick it up at the end of the lesson. Now let's talk about this ambiguous case, because using the sine law is something that you learned how to do last year, and that's not really the new learning. The new learning is this ambiguous case. So what is the ambiguous case? Well, when you're given the lengths of two sides and an angle that's not contained by the two sides, a unique solution may not exist. There might be no solution. There could be one solution, or there could be two solutions. And that's depending on the ratio of the side lengths and the heights of the triangle. This occurs because the cast rule gives us two possible solutions for an angle, as an acute angle or an obtuse angle, when we solve for an angle using sine law. And if you think about cast rule, you'll remember C-A-S-T, I could have an angle in either of these quadrants, a theta or a theta, that when I do sine of either of those angles, I get the same ratio because sine is positive in both of these quadrants. And that creates a little bit of a problem. Or it creates a solution. And the reason it creates a solution is because, well, sometimes there are two different triangles you can draw with the same ratio. And that's where the two solutions come from. Sometimes given information you can't actually draw the triangle, and that's where the zero solutions come from. And the one solution just comes from all of the times that you've used the sine law in the past and just got an answer. So let's talk about all the scenarios. If the angle you're given in the question is an obtuse angle, and I've just listed some information, like I've given you an angle and two sides. If the angle I give you is obtuse, you need to compare the lengths of the two sides. And basically it creates two scenarios. If I give you an angle and a side across from it, we could use the sine law if we're given another side. So here's two scenarios. I'm going to give you angle A, and it's going to be an obtuse angle. So I'm going to draw it. There's my obtuse angle. Now side A would be across from angle A, and the other side could be either of these. I'm just going to label this one the other side. There's my side B. If A is less than B, or A is equal to B, you won't get a triangle. And let's think about that for a second. I'm going to draw another side that's about the same length. Call that A. The reason you can't get the same triangle is because the obtuse angle in a triangle needs to be across from the biggest side. Because there's only 180 degrees in a triangle, and as soon as you get a degree that's bigger than 90, there's not another angle that could be bigger than 90 in that triangle. So if the side A, the one across from that big angle, isn't the biggest side, you can't actually build a triangle because the side won't be long enough to complete the triangle. And that's a problem. So if you're given an obtuse angle and the side across from it is not the biggest side, you can't draw the triangle and you can't find an answer. If the angle across from it is the biggest angle, if the side across from your obtuse angle is the biggest side, then you get a triangle. And this kind of makes sense because these would be all the questions that you would have been given last year to do sine law. I'd give you an obtuse angle and then I'd give you a side A, and it would be significantly bigger than all of the other sides because, well, obviously it should be. Angle A is huge. It's bigger than 90 degrees, therefore that side needs to be the biggest side. And that should almost just be common sense. Okay, at this point, proportional reasoning, biggest angle, biggest side. And if it's not the biggest side, you don't have a triangle. Where it gets interesting is if you're given an acute angle. Now, if angle A that you're given is an acute angle, there are 4 different scenarios. So let's look at the first one. Actually, I'll set it up first. If angle A, side A, and B are given, and angle A is acute, there are 4 possible cases to consider. For each scenario, the height of the triangle can be defined as height equals B sine A, and I'll show you why in a second. The first scenario is if the side you're given is less than the height. That means there's no triangle. And that one's similar to the no triangle in the other one. I'm going to draw this for a second. So here's my A, and I'm going to draw an acute angle. Okay, and we'll label this as B, as always. The height of a triangle is the vertical. That would be my height. And in this triangle, A is less than the height. So I'm going to draw a line that's about the same length. So let's look at the proportions here. A is across from the 90 in this right side of the triangle, so A should be the biggest side. However, if A is less than the height, we don't have a triangle, and that's what's happening in this scenario. A needs to be bigger than the height because it's across from the 90, and if it's not, we don't have a triangle, so we can't actually draw one. Back to this H equals B sine A, where does that come from? Well, if we look at this right side of the triangle, sine A would equal H over B. And to rearrange this, we'd multiply both sides by B. That's where we get our H equals B sine A. And no matter how we draw these triangles, that height equals B sine A will always be true. So keep that in mind. So no triangle if A is less than the height. A needs to be bigger than the height because it'll always be across from the 90 because height is drawn at a 90-degree angle. Now, if A and H are equal, there's a right triangle that exists. And how does that look? Well, here's my angle A. It's an acute angle. If A and H are equal, well, if A and H are equal, that's how we'd have A and H equal. A would be the height of the triangle, and H would be the same distance or same length. And in this scenario, we do get a triangle, and it's a right angle triangle. So we'll have one solution in that scenario. If A is bigger than B, you'll get one triangle. And what would that look like? Well, we got A, there's B, there's A. I'll draw my height on. Height doesn't really factor into this one, but since A is bigger than B, we definitely have a triangle. And the reason we have a triangle is because that height would definitely have to be less. The unique scenario we have here is where we get 2 possible triangles. We get 2 possible triangles when the height is the smallest and B is the biggest. So let's look at what this triangle would look like. Here's one scenario. There's my height, there's my A, here's my B, because that would be angle B. In this scenario, the B side's the longest, the A side is the second longest. That just means angle B is bigger than angle A, and the height is the smallest. And the reason there's 2 triangles is because I can draw this 2 different ways. Here's the other way. Sometimes the height can be outside the triangle, and that's the case in this one. So there we go. In these 2 scenarios, we could have 2 different angle B's that lead to bigger side B's. We could have an acute angle that's bigger than A, so say we had like 30 and 40, or 50 and 60. That might be a better example. Say we had 50 degrees for A, 60 degrees for B. B is still bigger, which makes side B bigger. In this scenario, we have an angle like 110, and A is something like 30. Two different angles that create two different B's, but also give the same ratio, same sine ratio. So those would be like a primary angle and a related acute angle that end up in the first and second quadrants. So a pair that we could consider conceivably would be something like, say, 60 degrees for B and 120 degrees for B. Both would lead to two different sine ratios that give you positive answers, or two different angles that give you possible sine ratios, two possible positive sine ratios. And that's why we have two different possible triangles that exist. So what's this change for how we do trigonometry? Well, basically, if you're given an angle and a side and one other side, there's a little test that you need to do first. And that test is you need to do the height test. Test the height of the triangle and see if the height is smaller than the two sides you're given. If the height's smaller than the two sides you're given, you need to consider that maybe there's two different triangles that exist. If the height's bigger, well, then you don't have a triangle. So let's look at an example. This says solve triangle ABC if angle A is 42 degrees, side A is 12, and side B is 15. Well, I'm going to draw a triangle, ABC. And what are we given? We're given A is 42, side A is 12 centimeters, side B is 15 centimeters. And let's do our height test. Height will always be B sine A. Now, if the letters you're given aren't A, B, and C, sine A is the angle you're given, so A is the angle, and B would just be not the opposite side. So if you're given an angle in a question and it's matching side, for your height test, you're going to use the angle and the other side. That's your height test. So let's see what we got here. We got 15 sine 42. That's 10 centimeters. Now, if I draw my height on here, there's my height. Let's look at the comparison. Height's the smallest, A's the second smallest, and B's the biggest. Height's the smallest. A is next, and B is last. B's the biggest, height's the smallest, A is in the middle. Let's go look at our four scenarios. In our scenarios, we've got height's the smallest, A's middle, B's biggest. Two possible triangles exist. So we need to draw a second triangle where the height is outside the triangle and B is an obtuse angle. So we've got our first one drawn. Let's draw another one. We've got our A is 42 degrees. There's our B, there's our C, there's our A. A is 12, height is 10, 15, angle, and 42. So how do we find, well, the other angle that could give us this triangle? We can find B using sine law, but when we use B finding sine law, how do we get the other B? Well, that's where you have to think about the angles on the Cartesian plane. The relationship between the two B's are that B is an acute angle, and this obtuse angle would be a primary angle, or an angle from standard position. And the relationship between the two is that B will always be the related acute angle to the principal angle, the obtuse B. So what's the relationship? Basically, the relationship is that they add to 180 degrees. So if you do sine law and you get 60, There is also a triangle that exists where B is 120 degrees because the relationship is related acute angle and principal angle. So the question said solve the triangle, so we need to find the other sides and angles. So I'm going to use sine law to find B. I'm finding an angle, so I'm going to put my angles on top. Sine B over B. And my pair is my A's. So equals sine A over A. Fill in what I know. And the earlier video, or the earlier example, I showed how to solve for a side. Solving for an angle is actually one more step. I'm going to isolate for sine B by multiplying by the bottom, which makes 15 sine 42 over 12. And then the last step is I got to do sine inverse of the entire right side. And you could find the ratio first, but then you have to round. So what I'm going to suggest is instead, you get used to typing the whole thing in your calculator. Sine inverse of 15 sine 42 over 12. But you're going to find what works best for you, and maybe breaking it down step by step works best. But either way, we need to be able to come up with an answer of 56.8 degrees. That's our B. So that's one of the angles. That would be B. And I know the question said solve the triangle. We're not actually going to finish solving it. You can finish solving it and check your answers on the course website. But now that you have two angles, you would find the third by subtracting from 180. And then you would use sine law again to find side C. And that'd be good practice of sine law, so I'd suggest doing that. But the whole point of this example is to illustrate that there is a second angle B. And there's a second angle B because of the height test, and the height ending up smaller than the other two sides means the height can be inside the triangle or outside the triangle. And because of that, we can get two different angle B's, an obtuse and an acute. How do you get the obtuse? Well, in this triangle, you can't do sine law, because if you do sine law, you're going to end up with this. So to get B, you actually have to do 180 degrees minus the 56.8 degrees that you got in the first triangle, and that gives you 123.2 degrees. And that's your B in this triangle. And now, if you solve this triangle, you're going to get a different C, and you're going to get a different side C. And that's the two different triangles that would give you, or that you could create from the given information in the question. How else could I pose this question? Well, I could pose it and say, determine all possible values for x. And if we look at this triangle, the way it's drawn, you're given a pair and another side, which is the same scenario that's drawn in the top four examples. And that angle is an acute angle. So we do need to do the height test here to see which scenario we have. And if we call this A, makes this A, and we call this B, and that's our angle B, we can do our height test again. Height equals B sine A. B is 14, sine 30. 30 is one of those special triangle angles. And if you remember, sine 30 is a half, and a half of 14 is 7. So the height is 7 centimeters. And in this scenario, the height would be the smallest, A is next, and B is the biggest. We have that scenario where we have two triangles, which means that when we solve for B, we might not get the one that this clearly looks like an obtuse angle. Now, because diagrams aren't drawn to scale, we could say that this is either the acute or the obtuse, but the way it's drawn is clearly the obtuse. So if we do our sine law and we get an acute, we have to change it to the obtuse. Even though both those values are technically possible algebraically, the diagram would lead us to believe that this is the obtuse angle. So let's do a little bit of math here. We'll set up the sine law. I'm going to use B's and A's because that's how I set it up. We're looking for angle B, so sine B over B. equals sine A over A. Fill in what we know. Sine, I'm going to use the x angle now because that's how it's designated in the question, over 14 equals sine 30 over 8. And now I'm going to rearrange and isolate in one step. In the last example I did it in 2 steps, so if you want to break it down in 2 steps, that's okay. And if I type that into my calculator, I get that x is approximately equal to 61 degrees, which is a possible algebraic answer, but because the way the diagram's drawn, x is probably 180 degrees minus 61, which would be 119 degrees. That degree sign fell a little bit, but it is in fact a degree sign. Those are the possible algebraic answers, but it's more than likely the obtuse angle because of the way it's drawn in the question. Okay, pretty challenging concept to understand. It is hard to remember these scenarios, but really the 2 scenarios that you need to remember are the one where no triangle exists and the one where 2 triangles exist, if it's acute. If the angle you're given is acute and the side is less than the height after you do the height test, sorry, the A side you're given, the A across from the angle you're given, is less than the height, we have no triangle. If the height's the smallest and the side that you're given that's not the pair, B, is the biggest, you're going to have 2 different triangles. The relationship between the 2 angles for B that you get in those 2 triangles are that they will add to 180. So if you do sine law and you get the acute, you can do 180 minus the acute to get the other obtuse. So a little bit of work left for you. Finish solving both the triangles to show that there are 2 different angle C's and 2 different side C's. And there was one question on the previous page that you could give a shot to. That's it for lesson 5.6. We'll talk some more about the height test in class because it's a pretty challenging concept and my explanation of it may not have been the best. So I'll give it another shot in class tomorrow. Thanks for watching and I'll see you next time.